Okay, so who is ready with the presentation? Vaibhav, is that Vipul, is that you?
Yes.
You only texted me yesterday, right? You are ready with the presentation.
Yes.
Okay, go ahead, get started. Make it quick. Well, then we'll start with hierarchical. Savan, by the way, what's the status with you?
सर हो गया लगभग हो गया
Today, will you be able to present today?
या आई कैन
Achha, after Vipul, you will go.
या ओके
ठीक है, चलो Vipul, get started quickly.
Sir, is my screen visible?
Yes.
Okay. So I've taken the data where I've taken years of experience as the predictor variable and the salary as the target variable over here. So as you can see, I've taken the data of seven, like the employee with 7 years of experience, which who has salary of 80,000. The salary is in thousands of dollars. So for 5 years of an experience, the employee salary is like this. So I've taken the data over here, and so using regression trees as a base learner, we can create an ensemble model to predict the salary over here. So for the sake of simplicity, we can choose the square loss as our loss function, and our objective would be to minimize the square error from this model. So the first step goes like this. The model should be initialized with the function f0x, as you can see over here. And the f0x should be a function which minimizes the loss function or the mean square error. So in order to minimize the square error, we can take the first differential of the above equation, that is this equation. So as we know, like this is the mathematics parts that differential. If we take differential of the equation, we can find the minimum of that particular function. So this function is the square loss function. So if we take the differentiate, if we differentiate with respect to gamma, we will find uh, the exact minimum where the function is minimum. So it is observed that the function minimizes at the mean. So that's the reason why we are taking mean over here of this um, dependent variable. So then in the first stage of the model, we have taken the mean of this salary, that is this salary mean, and it is coming out to be 134. So now the step two would proceed as the creating of the, like we can use this residual um, from the previous table to create this h1 this create to create this h1, and which is nothing but the regression tree, and which will try and reduce the residual from the previous steps. So the output h1x won't be a prediction of y actually, and instead of that, it will help in predicting the successor function of the f1x, which will bring down the residual. So we have created the additive model. Like I have plotted the regression tree over here, and what I have taken, like what we have done over here is we have taken x is less than or equal to 23 as our left side of the node, left side of the tree, and we have taken the residual associated with that. So 50 minus 52, minus 54, minus 31, minus 16. So like this residual we have taken. For x is for x is less than or equal to 23, the mean of the residual is coming out to be minus 38.25. And for x is greater than or equal to 23, that is this the years of experience which is greater than 23, the mean is coming out to be 25.5. So so we have added the values over here, like these mean values of the residual for the respective years of an experience. Then this additive model H1X, it computes the mean of the residual, that is y minus f0 at the each leaf of the tree. So we can call this function f1 as the boosted function, and it is obtained by the summation of f0 plus h1 over here. And in this way, the additive model H1X, which it learns from the residual of our previous model F0, and it suppresses in the next model, that is H1X. So this procedure can be repeated for two more iterations. So like that, I have taken similarly, I've taken the left side of the node as x is less than or equal to 34, and the mean of the residual is coming out to be 6.75. So this 6.75 I have put over here for the values which are less than or equal to 34. And for x is greater than 34, the residual mean of the residual is coming out to be minus 27. So I put it over here. And then in the similar fashion, I have calculated the f2 over here, which is nothing but the addition of f1 and h2. So it is coming out to be 102.5 for the for the values or the data which are less than or equal to 20, and for 25 to 34 years of an experience, I'm getting the f2, that is the boosted function f2. It is getting as 166.25, and then I've done the one more iteration, that is H3x. So in this H3x, I have taken the left side of the left side of the tree as x is less than or equal to 28. So this residual average for x is less than or equal to 20 is coming out to be minus 10.083, and for more than x is more than 28, it is coming out to be 15.125. So we can make the equation in general as this each additive learner HMX in generalistical way, we can say, will make use of the residuals from the preceding function f1 minus h f1 minus uh, f1 minus 1 of x. So and if we actually see the mean square error of the f0x, that is 134, it is coming out to be 875. For f1x, the mean square error is coming out to be 692, and for f3x, it is coming out to be 550. So just simply by using the weak learners, we can bring out the huge reduction in the mean square error. So as we can see, it is reduced from 875 to 550. And one more observation over here, that I have plotted years of experience versus salary for this F1 model, F1 um, F1 boosted function. So the like the pattern is like this, and I've plotted the graph that residual versus years of an experience. So that it is observed that the boosting learner makes use of the pattern in this procedural error. So if and how to check if we have achieved the accuracy or not, that at the stage where the maximum accuracy is reached by the boosting, the residual appears to be randomly um, distributed without any pattern. So in the first stage, that the pattern, there is specific pattern in the residual errors, and if we achieve the accuracy, the pattern, like the residual appears to be randomly distributed without any pattern. So this was the intuition behind the XG boost.
Where is the residual plot for F3?
So actually, I have not plotted it. Just this residual calculation is remaining,
Okay.
and after that, this is like we can plot it over here.
Okay. Great. Good explanation. So, guys, do you have any questions in this? Okay. We'll take silence for a moment. Okay. Great people, you can stop sharing now. Let's have Savin.
सर मेरी थ्योरी और डायग्राम बेस चलेगा ना?
चलेगा.
तो वो स्टेप 1 में विपुल कैन यू प्लीज एक्सप्लेन दैट फॉर्मूला? Is it gamma formula?
What?
In step 1 you have written that formula, mathematical formula. Is it gamma's formula or what?
Actually, this is the formula for the calculation. Like it is the formula of the mean square error. So this is the mathematical intuition behind the credit XG boost.